So there's a programming club on campus. It's called Tech End. One of our student TAs, Trey, is one of the leaders of the club. He just wanted me to share. There's an event tonight. If you're interested, fill out the Survey Monkey, because I think they ask what kind of pizza you want. It will be today at 6. So literally you could come into lab from 5 to 6, and then it's right across the hall if you're interested. The one that I'll also plug is just if you generally want to join the club and at least get emails. I think there's like no harm in filling out this first link. And then if the stuff that the club's doing isn't interesting to you, then you can just unsubscribe from the email list and you can stop getting emails. But I think there generally isn't a harm in seeing what's going on in the Morehouse tech community. And the benefit here is you get to meet some of the upperclassmen that are doing CS. And that can really be cool to see, like, get their advice, get their experience from the classes they took, and any industry work they've done. Yep. Cool. Any questions here? People got the links if they want it? Okay. If you're going to go for the event tonight, try to RSVP soon so that they can place the food order. Okay. So for today, we're going to talk about nested statements a little bit more. I'm realizing the concept of nested statements is a little bit hard, and it makes sense because, like, syntax-wise, it's the same, but to actually understand what's going on with nested statements can be a little bit confusing. So we're going to spend a little bit more time with that, and we're going to use as a motivating example in the latter half of class the snowman example. It's also known as, like, hangman, if people played that, but I've heard hangman isn't super PC, so we're going to use a snowman example. So we're going to today recap the number guesser game, go over nested if statements one more time, and then play snowman and write some of the code for it. Any questions on anything before we get started? Yep. Okay. So we'll start with recapping the number guesser game. So first, just slides. I know we've seen this one a lot. While loop syntax, keyword while, condition in parentheses, condition must be true or false, and the code inside of the curly braces will run as long as the condition is true. The two common errors I'm seeing, sometimes people put an else statement after the while loop. Nothing goes along with a while loop. A while loop is just its own standalone structure, and once the while loop is done running, then any code after the while loop will run. So you don't have to put else do something else, right? It will just automatically run after. The second common mistake I'm seeing is people put like one line of code in the curly braces and then put the rest of their while loop code outside the curly braces. Again, the curly braces are to show anything between them is going to run repeatedly. So if you want something to repeat, you need to put all that code inside both the curly braces. One thing when you type it out, I'd encourage you, like when you type the open curly brace, immediately put the closing one. Your code editor might do it for you, but make sure you immediately put that closing one, and then you can hit enter a couple times. Just that way you don't forget the curly brace later. And you can tell where exactly your code should go between. Yep. Any questions there? Okay, what were the two requirements we said for a while loop?
Condition has to be true, but at some point false.
Yep. So the condition might be true initially, but at some point it has to become false. And so this usually involves using a variable in the condition. And what's the second requirement?
The variable has to be able to change.
Yes. And I like that general word that you gave. The variable must be able to change at some point. Yeah? So usually we put this at the end of the while loop. Does anyone remember what happened if we tried to change the variable at the start of the while loop? Yeah.
It interferes with the code after that. It
Yeah.
changes the variable before it's fully processed through.
Exactly. So the while loop condition is only checked once each loop. And so if we immediately change the variable at the start of the loop, there's a chance it might not do what we want. If we were printing all the even numbers up to 20, and we add 2 to the number at the top of the loop, then we might also print out 22. Okay, so in number guesser, just as a recap, we had a while loop, and what was our condition in the while loop? Does anyone remember? Yeah, so for number guesser, the user was trying to guess the correct number. So first off, is this going to be a validation problem or a counting problem?
Validation.
Validation, because the user might guess it on their first try, they might guess it on their 50th try. We don't know. So in our while loop, in our condition, just in English, what were we generally trying to check?
If they guess the number correctly.
Yeah, and so specifically, we want it to be true if the user's put in bad input. So while the guess doesn't equal the correct answer, then we enter our while loop and we tell the user whether their guess was too high or too low, and then we get another guess. How did we tell whether the guess was too high or too low inside of the while loop?
The if statement, the nested if statement.
Yes, we put an if statement inside of the while loop. And we said if the guess was less than the answer, it was too low. Else, if the guess was too high, we told him it was too high. So I guess I should have put up the screen first. But what was the condition? So now we said it in English. What would it be in terms of code?
It's like guess, explanation of something equals number.
Yeah, so we'll say the answer is 58 in this example. So while guess doesn't equal 58, and then what do we put at the end of the loop?
C and guess.
Yeah, so we'll tell the user, we'll print out whether it's too high or too low, and then at the end we'll have the C and guess, so we get another guess. Okay, so I'm gonna pass around some paper, and we're gonna practice writing pseudocode for this problem. Can someone remind me what pseudocode is? Yeah, so kind of English. It'll look like code, so we'll write the lines one line below the other, so vertically look like code. This problem has kind of most of the code, but not everything, because we still need to include our if statement. But yeah, I will pass around paper in groups of 2 to 3. We'll write the pseudocode for this. Yeah.
So in the nested statement,
Yes.
usually guess is greater than 52, we have a true or false.
Yeah. It would just your true and false would change. There you go. Yeah. All right, I'll have you two go together here.
Are you talking to people on LinkedIn?
Actually, can we use your paper? I'll make it more sheets. Thank you.
So it's really just
Go together.
Instagram.
Do you agree? Want to go
Free will comment on it.
Are you posting?
About the comments that was
Go together here.
No, check Brooklyn's page.
All right. I'm out of paper, but we're not So again, the pseudocode. So we're kind of just writing in English a summary of what's happening in this program.
This number is statement.
Yeah. So this program here.
You understand what to do?
If you have questions on how to get started, raise your hand. Come around.
Guess is not
But you pass the right policy, you just write that in there.
Okay. Sounds good.
So I'll put prompt for user. And then ask a guess.
All right, I'm not hearing too much discussion. Make sure you help the person who's writing.
Wow, I'm getting a equal number. And then, no, but I mean, it doesn't get us.
Oh, I don't know if you get us to.
And then approach that to see whether the number is bigger, the guess is bigger, or less guess. That makes sense.
And then have on the side.
How much over or under. But the whole point of the guess number is to tell them what the guess is.
There's a higher or lower.
That's what I'm saying.
Guess is
Quiet, let's- I understand what you're saying though.
So within the
Yes.
I'll give people one more minute, and then we'll bring it back.
You don't want like, you don't want to like whisper it. Yeah, you gotta ask for, you gotta put it in the pseudo code too. You gotta be like,
Okay, let's bring it back. Okay, so I think this is the hardest part for a lot of people that start programming is taking a real world problem and figuring out how we're going to design it. I think people are starting to get pretty good at kind of the syntax for how we write it. But now, especially for this next month or two, the challenge is really going to be how do we design problems. And so I'd encourage you before you start coding to just think about like a summary of what you're going to be doing. So what's kind of like the first summary of these first 3 lines?
first we're gonna get ask for input.
Yeah, so we'll just
Ask for number.
ask user for a guess. So note, we're not writing down like cout, cin, variable. We're just giving a summary in English, right? Does everyone follow? Like we're just saying ask user for a guess. That's the first part of this problem. And then what's the next thing that we have to do in this program? So we have a guess from the user, and what are we checking? Yeah, so we have a while loop, so we can write the word while, and we'd kind of said it in English earlier. Like, what are we trying to check in here?
Well, I guess doesn't equal to the.
Yeah, well, guess doesn't equal 58, right? So even someone who doesn't know how to code should be able to look at this and understand what's going on. While the guess doesn't equal 58, what do we want to do?
Tell them if the number's too high, too low.
Yeah, so we want to tell them, is the number too high or too low? So we could even just put something like, tell user if guess is too high or too low. So that could be like the first thing you do. If we wanted to like break this down so that it has like kind of the structure of our code, then we could switch this to here. So we'll leave this as like a comment. Tell user if guess is too high or too low. And the way we'll do that is, what's like the keyword if we want to branch? Yep, so if guess is less than 58, then what do we want to do?
Tell them it's like lower.
Yeah, we'll say like print guess is too low. Okay, and then what's the keyword for the other case? Yep, we can do else. And what do we want to print here?
Guess it's too high.
Okay. Why do we not need a case for in here if guess is equal to 58?
Because it wouldn't run if guess is equal to 58.
Why won't it run if guess is 58?
Because the condition for the while loop is that the guess doesn't equal 58.
Yes. So with nested statements, everything inside of this while loop assumes that guess doesn't equal 58. So when we're doing this if statement, we know at this point guess can't be equal to 58. Does that make sense why? Okay. So we know guess can't be 58 because everything in here we know this condition is true. So it's not 58, so it's either less than 58 and we say it's too low, or we say the guess is too high. And then what's the last thing we want to do in the while loop? So right now we're still in the while loop, so we can't be printing congrats because we know everything in this while loop is not equal to 58. Yeah, so just in English we'll just say like get another guess or ask user for another guess. Yep, so ask user for another guess. And now outside of the while loop, what do we know for everything outside of this while loop? Yes, at this point, we know guess has to be equal to 58. Otherwise, our loop would have kept running. So what can we do here outside of the while loop?
You can do like while or if, right? You can do like while guess is equal to 58, C out.
Then you would have an infinite loop though where we just keep printing out congrats. Like if we did here like while guess is equal to 58. And then we did like print congrats. like at this point, guess is always 58. So we're gonna print out congrats forever, right?
Yeah.
So instead of doing it in a while loop, what can we do?
We did it, yeah.
You don't need any condition, you can just see
It's
how
already.
Yeah. So why do we not need an if statement here?
Because it's always 58 over there.
Yeah. So after this while loop has run, pretty much while the guess wasn't 58, we kept asking the user for another guess.
Yeah.
And so eventually the user is going to put in 58. And once the user puts in 58, then all the code down here, we now know guess is always 58. Does that make sense? Like why is guess always 58 at this from this point onwards?
because the other condition was everything that was 58.
Yeah. So we kept running this while loop until it became 58. And then once it became 58, now we can just print out congrats. You guessed the number. So note, like we didn't need an else statement, we didn't need an if statement. We just know after the loop, we have the correct input. And so we can just print once. Congrats, you guessed the number. Yeah? Okay. Are there any parts here that don't make sense? Either how we got to a certain part or just looking at it now? Okay, for homework 5, this is one of the problems to actually code it out. You could literally like take this pseudocode, put it in your code editor, and the only things you would have to change is, you know, instead of this word ask user for guess, you would do cout and cin. Here you would do guess exclamation point equals 58. Here you do guess less than symbol 58, and then you just have to cout the right stuff. But if you understand the pseudocode, writing the actual code should be like a direct mapping. Yeah? Okay. Okay. I want to talk about this pseudocode one more time. So this is for the rock, paper, scissors problem in homework 4. A fair amount of students have been emailing and coming into office hours confused about this. So if you've been confused, don't worry. Like other students have had similar difficulties. I guess I need to try to figure out where the challenge is from going from the pseudocode to actually coding it. So as a recap for this problem, we first start by getting inputs from the user. And I think looking at students' code, people get that. They ask for the user move, the opponent move, the user rating, and the opponent rating. And so looking at people's code, people really understand that part. But then people are getting very confused in this if-else statement. So let's step through, and if anything is unclear, please let me know so we can try to address it and so you can do the homework. So this first line, if user rating is better than the opponent rating, how would we write that in code?
If user rating is greater than opponent rating.
Yeah, it's like we have these two variables, right? User rating and opponent, like operating variables, and we can just use the greater than symbol. Yeah? Everyone with me? Okay. And if that's the case, if the user is better than the opponent, then we know the user is the favorite. Yeah? So that means all the code between these two brackets, the user's better. Like even though we have another if-else statement inside of it, everything in here means the user is the favorite. And everything in the else case means the user is the underdog, right? Okay. So we have half the problem. The other half is if the user is the favorite, based on whether they win, lose, or tie rock, paper, scissors, their rating changes in some way. And so that's why we put this nested if, else if statement inside of the case where the user is the favorite. So in this block here, where the user wins rock, paper, scissors, and we add 2 to the user's rating, 2 things are true at this point, if this line were to run. What are the 2 things that are true here?
User wins and the user is better.
Yes, both of them are true. So I think people are understanding the user wins rock, paper, scissors here, but then they're forgetting that the user is also better than the opponent. Because we literally take this piece of code and we put it here as well, but we change the ratings. And I think people were a little bit confused, like why we had the same code twice. So it won't fit on one slide, but what the full pseudocode would look like. It would look like this, but these would be different values. Because in this second case, what does it mean here? If this code were to run, what are the two conditions that are true? Yeah, so user wins rock, paper, scissors, and they're the underdog. So even though we have the same code, like user wins rock, paper, scissors, user wins rock, paper, scissors, what's different is whether the user is the favorite or the underdog in both of them. So in this case, when the user was the underdog and they won, then we added 3 to the user's rating, right? If they were the underdog and they tied, then we added 1 to the user's rating. And then I forgot the last one, but I think it might be subtract 2, right? If they're the underdog. So I think what was tripping people up is it looks like we have the same code twice. It looks like we have this here and we have it here. The difference is this outer if statement is different, right? So in this one, the user lost and they're the favorite, whereas here, the user lost and they're the underdog. Do people follow what's going on there? Okay. So again, you could, I would encourage you to take a photo of the pseudocode because you can just put this into your code editor and the things you would have to change, like using the actual variables, user rating and operating. And then here, user wins rock, paper, scissors. People wrote this code in lab 4, right? There was like the big statement, like if user move was equal to paper and opponent move was equal to rock, and there were like the 3 different cases. So you literally just have to take that code and replace the pseudocode. Yeah? All right. Any questions there? Again, if you have questions, you can come into office hours. Yeah.
I would just say, I had it confused with this was all done around the brackets.
Okay, yes.
That's what I was getting errors with.
Yes, I agree. Keeping track of all the brackets is really hard. And that's where I know the indentation is optional for the computer, but it almost becomes mandatory for us as humans just to understand what's going on. And so if you notice, even in the pseudocode, you can tell everything in this indentation is the big if else, and you can tell the brackets match, right? And this one to here. The next level is this if else if else if. And you can see this bracket matches here, this one matches here, this one matches here. And if one of them was gone, I would be able to tell based on the indentation that something is missing before this other bracket comes, right? And so again, when you create your if statement, make sure you put the open and close bracket immediately and then just press enter a couple times. That way you have space to then write your next code. That could also be where having the pseudocode initially helps because it's easy to, when the code is smaller, to make sure your brackets line up. And then you can go in and change, instead of user wins rock, paper, scissors, then you type in the big statement. But you at least know before you start typing it in that your curly braces are correct. Yeah.
So do you use pseudocode first or flowchart?
So I'm teaching both because some students prefer or learn in different ways. So for me personally, when I go to code, I find pseudocode easier, especially because it has the whole structure set up. But for some students, it's easier to visualize it in a diagram first and then use that to code. So you should know how to do both, but which one you end up doing is up to you. Yeah.
Is there a way to collapse the code, an if statement on Excel, to make things easy to see?
That's a good question. I know in some code editors you can. I'll take a look and get back to you. Yeah. Okay. Any other questions? Okay. So Friday's lecture. So again, the midterm is going to be on Wednesday. So Friday's lecture is going to be reviewing topics that people want to cover again. Monday's lecture is going to be a practice exam. So we'll treat it just like a real exam, but I'll go over the answers with you. So we'll maybe make the practice exam half as long as the real exam. and then Wednesday will be the midterm in class. Okay, so I want to kind of get a poll based on what students want to have covered in Friday's lecture. So I'm going to have you all close your eyes so that you're not influenced by other people's votes. But generally what we've covered so far in the class, and I'll kind of ask each of the big categories, and you can raise your hand if you want more practice with it. So kind of we went over data types, variables, arithmetic operators is like plus, minus, divide, multiply, mod. Relational operators, less than, greater than. Logical operators, the and the or. If-else statements, nested statements, and while loops. Okay. So I'll have everyone close their eyes, and it'll just be raise your hand if I say a topic that you want covered. So everyone close your eyes. Data types. Okay. Variables. Arithmetic operators. Mod, plus, minus. Relational operators. So less than, greater than. Okay. Logical operators. And, or. Okay. If statements. If, else. Okay. Nested if statements. Okay. While loops. Okay. All right. Any topics that I maybe didn't say that you would want covered? I think those might have been the big ones. Yeah. Okay. Yeah. The less than. Okay. So that's like relational operators. We'll do a little bit with that and logical operators. Yeah. All right. Yeah.
And then what's it called? When you physically draw out or even pseudo.
Oh yeah, flowchart and pseudo. Okay, yeah. Yeah, we'll do one more flowchart example because there will probably be a problem like that on the exam. Okay, cool. Anything else? Yeah.
Will there be nested while loops on the testing?
No. There might be the nested if statement though. Just we won't have two while loops. It could be a while loop with an if statement inside. Any other questions? Again, the exam will go up to while loops. So honestly, if you're able to do all 5 labs and all 5 homeworks by yourself and you feel confident on that, you'll be in very good shape for the exam. So that I would still put that as the best way to study. And then we'll talk a little bit more about how to study on Friday. Okay. So for nested if statement, we talked again about while loop syntax looks like this. The nested if statement, I should have put this on the slide earlier, but essentially, if this code runs, this part in condition 2, 2 things are true. First, condition 1 is true. Whatever was in the while loop condition, that has to be true. And whatever's in condition 2 has to be true as well. So in the number guesser problem, when the guess was greater than 58, we knew 2 things were true. First, that it wasn't equal to 58 in the first condition, and that it was greater than 58 in the second condition. Right? You could write the same slide for if statements as well. Like you could switch this while to an if, and this slide would look exactly the same. Where this would be both conditions are true, this one is condition 1 is true, and the second condition is false. Does that make sense to people? It's almost like using the and logical operator, right? It's like condition 1 is true and condition 2 is true for that first one. Okay, so snowman. Okay, so the way this game works, we guess a letter. If the letter's not in this phrase, the snowman starts melting, and we want to try to guess the word before the snowman fully melts. So can someone give me a letter? All right, we'll go with A. 2 A's in the word. I. All right, no I, so we lost an arm. What letter?
E.
E. Okay, couple E's. T. All right, no T. There goes the hat.
N.
N. Okay.
H.
H. All right. S, yep, he's an M. All right, no. G, okay. Okay. R, Y, L, elf, okay. He's an angry elf. Nice. And we saved the snowman. Okay. So let's think about just in code how this worked. So when we guessed a letter like A, if you had to think about if you were to code this, like just in English, what would you do with the letter A? What would you have to check? Yeah, so we'll assume the user selected A, and now how can we figure out if A, like what do we do after the user selected A?
If the string contains the letter A.
Yeah, so we want to see, like, we have this big string, right? A string can be multiple words. And we want to check if A is in the string. And so if we were to break that down a step further, we would essentially check, is A equal to this letter? Is A equal to this letter? Is A equal to this letter? Right? And we check for each letter, is A equal to that? So if we were to like put in A, we would like check A is not equal to this letter, not equal to this, not equal to this. We keep going, and then we'd say, oh, A is equal to this letter. And we would replace the dash with the letter A. So for today's class, to replace a letter kind of requires a little extra knowledge, so we're not actually going to replace the letter. But for today's class, as a motivating example, we're just going to see how we can figure out if the letter A is in the string. And then in a couple weeks, we'll then see how to replace the letter to be the actual letter A. Okay? So you'll notice that I kind of said the same thing over and over again, right? I was saying if this is A or it's not, if this is A or it's not, if this is A or it's not. That should be a good indication to you if you're doing the same thing over and over again to use what kind of data structure? A loop, yes, because we want to do the same thing 5, 9, 13, 17, 21, 26 times, right? We're doing the same piece of code 26 times. Is this going to be a counting loop or a validation loop? Counting, because we know exactly how many times we have to run the loop based on how long the string is. So in this case, if the string is 26 letters, we would run the loop 26 times. Yep. All right. So let's see how we can set this up. So one thing I'll talk about again, we briefly mentioned it at the end of one lecture. A string, if we had the string and we named it name, the variable name is name, and we assigned it the value max. Each string has what we call an index. So M is the 0th position, A is the first position, X is in the second position. In computer science, we start counting from 0. That's why in all of my overview table of content stuff at the beginning of lectures, I always counted off 0, 1, 2, 3 to subconsciously get people ready for this. So if we want to get the letter A, we would take the variable name. So we created this variable name, and then we use square brackets. So to get the first letter, the capital M, we would say name, square brackets, and you put the index. So we would put 0. If we wanted to get the letter A, we would put again the variable name, square brackets, and then the number 1. And if we wanted to get the letter X, what would we do? Yeah. Yep. So we would do name, square brackets, 2. Yeah.
So in the code, you're not going to use string name equals max. You're going to use the 2 code at the bottom to write out max.
So in order to use these square brackets, we need some string variable. So that's why, like at the top, we created the string variable named max.
So that would be in the variable area, and then that would be in the actual like coding area where you're writing max.
Yes. So I guess I could have put like string. I could have moved this to be right above it. Sorry, I don't know why I like put it separately. Your code could just look something like this. So like at the start of your code, you define a variable name, and you set it equal to the value X. And then if you wanted to get the first letter, like this would give you the letter M, and this would give you the letter A. I think the next example will help clarify it a little bit as well. Yeah.
Do we have to, when we're putting like string name or int, whatever, do we have to put like string first letter, string second letter to define it?
That's just what I chose for the variable name. You can choose what you want for your variable names.
But
So
I'm saying, like, it's already assigned to char, right? So we wouldn't have to put like string first letter, string second letter.
So char is the data type. So it's kind of like we always say the data type and then whatever the name of the variable is. So I'm creating a new variable called first letter and I'm assigning it the first letter in name. Yeah.
The char is a new data type.
Yes, depending on which lectures you've come for. we talked about it once in an earlier lecture, but yes, char is, yeah, a single character. Yep. So with the single character, it'll just have one set of quotes around it. Okay, any other questions? Okay. So we're gonna break this problem down into a few parts. So let's assume answer is 3 letters long. In the previous snowman example, the answer was 26 letters long, but we'll just assume the answer is 3 letters long. And the first thing we want to do, we're not even going to do any checks. We're just going to print out each letter on its own line. So we said it was a counting loop. What do we want to put in the condition so that we can get each letter in this 3-letter answer? We'll assume index is starting at 0.
While index is less than 26.
So we'll assume answer is 3 letters long this time. Okay, index is less than, so I've heard index is less than 3 or also index is less than or equal to 3. We'll revisit that. What should go here at the end of the loop? Yeah, so we'll do index is equal to index plus 1. So we want the loop to run how many times? 3. Index is 0 to start. So the first time 0 is, let's say we'll go with less than or equal to 3. 0 is less than or equal to 3, that's true. So the loop will run once. We increase index to 1. Is 1 less than or equal to 3? So we'll run a second time. Okay, we increase index by 1, so index is now 2. Is 2 less than or equal to 3? It is, so the loop's going to run a third time. We increase index by 1, so index is now 3. Is 3 less than or equal to 3?
Yes.
It is. 3 is less than or equal to 3. So the loop's going to run a fourth time. So we don't want to do less than or equal to 3. What do we want to do in this case? Less than 3. I know in the other examples we were doing less than or equal to, but that's because our counter usually started at 1. Yeah, but now because index is starting at 0, yeah. So because index is starting at 0, we just want to do it less than 3. That way index is 0, then 1, then 2, and then we stop. Right? Because in the max example, we only wanted to go up to the value 2. We didn't want to include the value 3. Okay, cool. And now, if we want to actually print out the letters in answer, what code line can we put right here? So we're not doing any check. We're just going to print out each letter on a new line. Okay.
First letter.
Okay. Yeah, so we could store it in a variable. We could also just do cout directly. So we could do cout, and what should we put after the cout? Answer bracket
1 or bracket 0, bracket 1, bracket 2.
So if we just did a number like that, answer bracket 0, we would just print out m 3 times. How can we make sure that we print out m, then a, then x each time in the loop?
Do we do an end line?
We'd have an end line, but what are we putting in the square brackets?
Answer bracket 0, answer bracket 1, answer bracket 2. Is that?
Yes, but we have a while loop. So what?
You put an index.
Yeah, so we know index is going to be 0, then 1, then 2. So if we just cout the answer, and in square brackets index, that will do what people are saying, right? Because index was 0 the first time. So the first time we're going to print out answer 0, which if our answer is max, it will print out M. The second time, index is 1. So we print out answer square bracket 1, and we print out A. And then the third time, when index is 2, we would have answer bracket 2, and we'd print out X.
Yeah, it makes sense.
Does that, any questions? This is a little bit confusing. We're kind of putting together a few different concepts here. So first, like, we know it's going to run 3 times. We want to do index 0, index 1, index 2. That's what this while loop condition and this index is equal to index plus 1 will take care of for us. So index will be 0 the first time, then 1, then 2. And this is just going to print out, and I guess I should have had, we want it to all be on different lines, so we would put like an n line as well. Okay. Questions there? Let's maybe quickly put it in the EdStem, just to really make sure people get it. Okay. So if answer, we put in the word max, and we're to run this, right? So the first time, and we'll also print out the index inside the while loop. Okay. So the first time, when index is 0, we print out answer of 0. So the first letter in answer, and that's how we got N. Second time, when index was 1, we print out answer of 1 to get A. Second time, or sorry, the last time, when it's 2, we print out X. If we were to put in a different word, or a different name, like Tom, it would still work, right? So this will work for any 3-letter name that we put in. What happened if we did less than or equal to 3? There's no like third letter here, or like in the third position, because that would technically be the 4th letter. Yeah? Okay. Okay, so that's how we printed. Now, what code could we actually put here if we wanted to check if, so we assume the user has guessed a letter. How can we check if the letter is equal to the thing we were printing out, either like the M or the A or the X? Yeah.
We do like letter is not equal to.
So in this case, we want to check if it is equal to, because we'll have like an if statement inside of here. So we can check if the letter, so we're on the right track. If letter is equal to what? Okay, what about the answer? So the letter's never going to be equal to the entire answer. Yes, one of the characters in the answer, so the index. So if the letter that the user guessed is equal to, before we were just printing out answer of index, right? Now we're just checking if they're actually equal, and if it is, then we can say letters in the answer. So let's move this code over. Okay. So again, we'll put in max as the answer. All right, and let's say we were to guess the letter A. Let's step through what's going to happen. The first time, index is 0. So what is this going to give us, this answer of 0? It's going to give us m. And is m equal to a? No. So we'll just continue by increasing the index by 1. So now index is 1. Is 1 less than 3? All right. And then what is answer of 1 equal to? A. And is a equal to a? Yes. So we would print out a is in the answer. And then we'll come and we'll go one more time. So now index is going to be equal to 2. Is 2 less than 3? What is answer of 2? X. And is x equal to a? No. So then we don't do anything. And so if we're to run this, we say a is in the answer. Right? But if we were to put something that's not, like the letter P, then it just doesn't do anything. Yeah? Questions? Okay. So let's do lab 5, due today. If you haven't done lab, make sure you come into today's lab at 5 p.m. Homework 5 is going to be due Monday, the 26th. Again, the best way to prepare for the midterm is to make sure you know how to do all the lab and homework problems. If you feel confident with that, you'll be in a great spot for the exam. Yep. Cool. Yeah, question? 1 sec, let me just stop the recording.